Hi, today we're going to begin working on Lesson 5, identifying proportional and non-proportional relationships in graphs. You had a chance to review graphs and coordinate pairs or ordered pairs, so that should be a good refresher as we're preparing to graph and check for proportionality. So as a quick review, let's take a look at this opening exercise. Isaiah sold candy bars to help raise money for his scouting troop. The table shows the amount of candy he sold compared to the money he received. Now, as we take a look at this, we notice that we have the x and the y. And if you recall, you have seen y equals kx, k standing for your constant, and of course x and y being your two groups here. So as we take a look, remember we talked about ratios, and we want all the ratios to be equivalent. So let's take a look, and remember we can also find k by doing y over x. So 3 over 2, which I could change that to 1 5/10 over 1. 5 over 4, or a 5-to-4 ratio. And that is 1.25 over 1. So if we take a look at these two numbers, that means that I have multiplied 2 times 1 5/10, and I've multiplied 4 times 1 25/100. So the fact that these two numbers right here are not the same means that our ratios are not equivalent. So there is no constant or no constant of proportionality. So they are not proportional. Candy bars sold is not proportional to the money that Isaiah received because the ratios are not equivalent. There is no constant or constant of proportionality. So hopefully that's a good quick little mini review. Let's move on to exploring this next part. If we look down here at this challenge, we're going to actually apply and move from a table to a graph, and you kind of have an experience with this when we did the bunches of flowers task at the beginning of this module. So down here, it's wanting us to use this ratio that's been provided to us, but they want us to come up with the other ratio so that it forms a proportional relationship. So if you recall, we're going to use something called scaling up. So in scaling up, remember that we take 2 and we multiply it times 2 and we get 4. We take 2 and multiply it times 3 and we get 6. And then we take 2 and multiply it times 4 and we get 8. So we now have scaled up, and we're going to follow that same scale over in my y's. So 3 times 2 is 6. 3 times 3 is 9. And 3 times 4 is 12. Now each one of these gives me an ordered pair. 2, 3, 4, 6, because remember your x comes first, 6, 9, and 8, 12. So when we come over to graph this, we want to definitely label. On this side, we're going to label it as the dollars. And this part down here is going to be the candy sold, because this is my x-axis and this is my y-axis. So my first ordered pair is x2, y3, x4, y6, x6, y9, x8, y is 12. Now let's think about something. If candy bars being sold, if I don't sell any candy bars, how much money can I receive? Well, that would be a 0, because no candy bars, no candy sold, would mean no money. And that is my 0, 0. Okay, so let's take a look at this. What do you think we're going to find when I actually connect these points? All right, connecting the points, and a straight line. So a couple of things that I want us to look at on this. We can actually check this here and see that, as I did in my previous example up above, this was 1.5. So if I check my ratios, remember for x, 3/2 is equal to 6/4, which is also equal to 9/6, which is also equal to 12/8. All of these can be simplified to 3/2, which is a unit rate of 1.5 to 1. So the fact that my table is showing proportionality is great, but how awesome is it that you can find proportionality in a graph based off of two things? The first is it a straight line? So yes, it is. And the second, and we can't forget this piece, is that it goes through the origin. And the origin is 0, 0. So if it meets both of those characteristics, then it is a proportional relationship. So as you look on the second part, on your paper at the top, it has the characteristics, and notice it already filled that in for you. So we're going to keep that in mind, that in order for a graph to show a proportional relationship, it must be a straight line that passes through the origin of 0, 0. Example 1 here, graph these points from the opening exercise. So this goes back to the very first one that we saw. So over 2 up 3, over 4 up 5, over 8 go up to 9. There we go. And over 12 go up to 12. Now, hopefully you can take a straight edge. It could be a piece of paper. I'll do it on this side. Here we go. And if you line them up, now a few of them look kind of like they're lining up almost correctly, but notice this one is not there. And in order for me to get it there, I'm covering or losing some of the others. To show you better, I can use this transparent one. So if I were to draw a straight line, let's say I connected the first and the last points. Okay. So if I connected the first and the last points, hopefully you're noticing that if I do that, a couple of things. One, it does not cross at 0, 0, and all the points are not on that line. So that means that these points will not make a straight line. So let's put them in color so we can actually see. And I'm going to connect point to point. So I can be more accurate. And hopefully you can see that this is not a straight line. Therefore, it is not proportional. So straight, it is not straight, not straight. And based off of how we graphed it just then, we don't know if it's going through 0, 0. So we don't, I could have connected this way. Many ways you could draw lines, but it is not a straight line, so it is non-proportional. And based off of this, it doesn't go through the origin either. So if we look at this next one down here, it's giving me my ordered pairs, 0, 6, 3 and 9, 6 and 12, 9 and 15, and 12 and 18. So again, we're going to start off and check our straight. Is it a straight line? It is straight. So that's great. But does it go through the origin? And remember, my origin is 0, 0. No, it doesn't. So therefore, it is non-proportional. So the similarities here are they didn't even have the same values of x's, but if we just compare those two graphs, the similarity is that they're both not proportional. And one of them is straight. Differences, one is straight, one is not. We know that one doesn't go through the origin and the other one, we just don't know. We don't have that data. So as a quick wrap up, I just want to again review. The characteristics for proportional relationships on a graph is it's got to be a straight line and it goes through the origin, which is 0, 0. Let's just do a very quick look at these different graphs and determine if they're proportional or not proportional by looking at them. First, 0, 0. Yep, we have the origin. Is it straight? Is it a straight line? Yes. So that means it is proportional. Let's go to the next one. Do we have 0, 0? No. So we can stop because it doesn't matter if it's straight. So that is non-proportional. Okay? Fourth one. 0, 0. Yes. Is it straight line? Yes. So it's proportional. We've got 0, 0. But obviously when you look at this, you see it's not straight. So it is not proportional. Okay, here, I'm not at 0, 0. So it's non-proportional. Here, again, remember, not at 0, 0. So it is non-proportional. It's that easy, folks. Down here, okay, if we connect, are you seeing that it's getting a curve? If we continue that line, it doesn't meet either. So it's not proportional. Here we're at 0, 0. So that's correct, and it is straight, so it is a proportional relationship. So hopefully these have given you some insights into how to check a graph for proportional and non-proportional relationships.